Welcome to the deep dive. Today, we're doing something a little different. We are zeroing in on what I think is the most intense part of any public company's report.
The Q&A.
The Q&A session. Specifically, we're diving into the dialogue from Nvidia's Q3 2026 earnings call. This is where the sharpest analysts really put the leadership to the test.
Right, because you get past all the prepared statements, get to see the executives, in this case, Colette Kress, the CFO, and Jensen Huang, the CEO. You see them have to defend their strategy in real time. Our whole mission here is to really pull out the answers to the biggest questions in tech right now.
Exactly. We're breaking this all down for you. We want to know, is this incredible demand for AI hardware actually sustainable? I mean, for the next 3, maybe 5 years?
And where is all the money for this multi-trillion-dollar build-out even coming from?
And maybe most importantly, what is the the actual roadmap with Blackwell and Rubin that's supposed to keep them so far ahead of everyone else?
Let's unpack what we found.
Okay, we have to start with the money. The numbers are just staggering. Joseph Moore, an analyst from Morgan Stanley, he didn't waste any time. He went right for it.
He did. He immediately asked for an update on that massive multi-year revenue forecast they put out for Blackwell and Rubin.
The $500 billion one.
The $500 billion one. And the update from Colette Kress was, well, pretty clear. She confirmed they are still on track for that colossal number.
So just to be clear, that's $500 billion in revenue from the start of the year through the end of calendar 2026.
Correct. And they just shipped $50 billion this quarter alone.
That kind of number, it just resets the entire industry. But, whenever you hear a company just reiterate a number that big, you have to ask.
Is it real?
Yeah, are they just, managing a backlog? Is that $500 billion a hard cap, or is there more fuel in the tank?
And that's exactly the point. Kress's answer here was, I think, really crucial. She made it clear that the $500 billion target is a floor. It's not the ceiling.
A floor. So they actually expect to take more orders on top of that.
More new orders. That will push them beyond that $500 billion number.
And did they back that up with anything? I mean, it's a big claim.
They did. She cited some specific, very recent, very large-scale deals. This showed it wasn't just about fulfilling old orders. This was new growth.
Okay, like what?
Well, the big one was the new agreement with Saudi Arabia, the KSA. That alone is set to add somewhere between 400,000 to 600,000 more GPUs over the next 3 years.
Wow. That's a nation-state level of commitment.
It's massive. And on top of that, she also mentioned the partnership with Anthropic as another net new commitment to future builds.
So when you put that all together, the existing backlog plus these huge multi-year contracts from governments and top AI labs.
It really paints a picture. The demand cycle isn't peaking. If anything, it seems to be broadening out and even accelerating. This is a long-term infrastructure shift, not just, a hot hardware cycle.
That's the perfect lead-in to the next big question, which came from analyst Christopher Muse. It's all about supply versus demand.
Right.
I mean, if all the cloud providers are sold out and you have these new, incredibly compute-hungry models like Gemini 3 and Grok 5 coming out what feels like every month, can supply ever catch up?
And Jensen Huang's answer was, I thought, really insightful. He didn't really talk about manufacturing or, bottlenecks in the traditional sense. He focused on the why. The fundamental drivers of demand.
Okay.
He basically said supply can't catch up because the demand is being fueled by 3 separate massive platform shifts that are all happening at the same time, and they all run on NVIDIA's architecture.
The 3 pillars of growth. Okay, let's walk through them. What's the first one?
The first is accelerated computing, and this one is really all about cost reduction. It's about economics.
Because Moore's Law is basically dead.
It's hit a wall. It's just too slow and way too expensive to solve these huge computational problems with old-school CPUs. So every data center is being forced to switch to GPUs. It's the only way for hyperscalers to drive their own costs down.
So that's one whole layer of spending just to save money.
A huge layer. Hundreds of billions in cloud spending moving over to CE GPUs. Then you have the second pillar, which is generative AI.
This one feels more like it's about making money, not just saving it.
It is. It's about modernization. Generative AI is replacing all the older machine learning systems that run the core of the internet search rankings, ad targeting, recommender systems.
And he gave a specific example, right?
A very concrete one. He said Meta's new GEM foundation model drove a verified 5% increase in ad conversions on Instagram.
5% on Instagram's ad businesses. I mean, that's an insane amount of money.
Millions. and a 3% gain on Facebook. So the point is, the investment in this infrastructure pays for itself almost immediately with real, tangible revenue gains. It's cash flow positive from day one.
And then there's the third layer, the newest one, agentic AI.
This is the completely new stuff, the stuff that couldn't exist before. We're talking about sophisticated systems that can reason and plan and use tools. Think about things like Tesla's full self-driving, or AIs that help discover new drugs, or coding assistants like Claude Code.
So if you step back, what you're saying is you have three enormous exponential waves of spending. One's to cut costs, one is to boost existing revenue, and one is to create entirely new products.
And they're all stacking on top of each other, and critically, they all run on the same Nvidia GPUs. That's how you get this relentless, diversified demand that just keeps outstripping supply.
That framework also seems to answer the financing question that another analyst, Vivek Arya, brought up.
It does.
He pointed to that forecast. Something like a $3 to $4 trillion data center build-out by 2030. How on earth does that get paid for?
And Huang was really granular here. He said those first two pillars, the accelerated computing for cost savings and the generative AI for hyperscalers, those are largely cash flow funded.
Because they pay for themselves.
They pay for themselves so fast, the investment is justified internally. But the third pillar, the agentic AI, that's the net new spending. And that's funded by all sorts of different sources: sovereign nations, specialized industry funds, enterprises who just have to adopt it or get left behind. It's a globally distributed funding base.
Okay, let's shift from the financials to the tech itself to the architecture. Because Arya also pushed on the actual dollar value of NVIDIA's content per gigawatt.
Which is such a critical metric, because you have to remember, data centers aren't infinite. They are power constrained. They hit a 1 gigawatt wall, and you can't just plug in more power. You have to get more performance out of every single watt.
So what's the trend? Is their value per watt going up?
It's going up significantly. The estimate was that the Hopper generation was about $20 to $25 million of NVIDIA content per gigawatt. But Blackwell, the Grace Blackwell platform specifically, that jumps to 30 million plus.
And Rubin will be even higher.
Expected to be higher again, yeah.
Yeah.
And the whole point is that they're taking a bigger piece of the data center budget because their hardware provides this huge multiplier on efficiency, which translates directly into more revenue for the customer from the same amount of electricity.
And this is where we get into their real technical lead, which seems to be in inference.
Oh, absolutely.
Analyst James Schneider asked a great question. Why is inference, the part where the AI actually gives you an answer, why is it getting so much harder and more expensive?
It's because it's not just a simple lookup anymore. The complexity has just exploded because of things like chain of thought or these advanced reasoning capabilities.
What does that actually mean, chain of thought?
It means that, to answer your question, the AI has to do a whole bunch of work internally before it even generates the first word. It has to read huge amounts of context, plan out its answer, filter information, run an algorithm. All that thinking takes a massive amount of computation, and it's driving the cost of inference through the roof.
And they claim their architecture gives them a, quote, multi-year lead here. Is there any way to quantify that?
Well, he pointed to the Blackwell NVLink 72 system, and he cited a major industry benchmark, the Semi-Analysis Inference Max. And in that benchmark, which uses real-world models, the GB200 system delivers 10 to 15 times higher performance than the next best thing.
Which is?
Their own predecessor, the H200.
So a 10 to 15x jump generation over generation, that's not incremental.
No, it's a step change.
Yeah.
And it's especially important for these frontier models that use what's called a mixture of experts or MOE architecture.
Right, which is like having a team of specialized AIs that all have to work together.
Exactly. And to get that team to work together efficiently, you need incredible bandwidth and speed, which is what that NVLink system provides. It's the key to making those giant MOE models work at scale.
And looking even further ahead, they talked about the Rubin CPX product. What's that designed for? What problem is it trying to solve that Blackwell doesn't?
The CPX is all about extreme long context. I mean, think about an AI agent that needs to read and understand an entire library of PDFs or a year's worth of video, or maybe complex 3D engineering files.
Not just a few pages of text.
Exactly. For those really deep, heavy reasoning tasks, the performance you get per dollar and per watt is everything. And CPX is designed to be the next huge leap in efficiency for exactly those kinds of jobs.
Which brings us to the competition. Analyst Aaron Rakers asked about ASICs, the custom specialized chips that a lot of the big cloud providers are trying to build themselves. What's NVIDIA's defense against that?
Yeah, this is a great summary from Jensen. He laid out 5 core advantages that their more versatile platform has over a single-use specialized chip.
Okay, let's run through them. This is basically their moat.
It is. First, their platform accelerates every phase of this whole transition, general purpose, generative, and agentic. Second, it's great at every phase of AI training, fine-tuning, and critically inference.
Third, it runs everything.
It runs every single frontier model. OpenAI, Anthropic, Gemini, you name it. Every major lab uses their architecture. Fourth, it's available everywhere. Every cloud, on-premise, at the edge, even in PCs.
And that fifth point was really about the business case for their own customers, the cloud providers.
Right, this is the clincher. Their versatility gives cloud providers off-take diversity. You don't want to fill your multi-billion-dollar data center with specialized hardware that can only be sold to one kind of customer for one kind of problem.
You want something that a biotech firm can use one day and a game developer the next.
Precisely. That broad utility is what protects the cloud provider's own financial model.
Let's shift to operations for a second. Timothy Arcuri asked about the single biggest bottleneck. Is it power? Is it financing? Is it the supply chain?
And the answer was, pretty pragmatic. When you're growing an entire industry at this insane scale, everything is a constraint.
Everything is the bottleneck.
Everything is the bottleneck. But he said they're confident because they have a super strong balance sheet, which they use to secure the supply chain, and they do deep, long-term planning. He mentioned their 33-year history with suppliers, allowing them to book capacity years ahead of these demand surges.
And finally, the financials, the margins. Stacy Razgon pushed the CFO on whether these incredibly high gross margins can last.
And Colette Kress was firm. The goal is to hold gross margins in the mid-70s for the next fiscal year.
How? I mean, everyone knows the input costs for these things are going up.
Through internal efficiencies. They plan to offset those rising costs with improvements in their own processes, better cycle times, and managing the product mix. She also made a point that their operational spending, their OpEx, is very targeted. It's not just growing across the board.
It's all going into R&D.
It's focused purely on engineering and innovation to support these really fast architecture ramps, like getting Rubin ready for the second half of 2026.
So after this whole deep dive into the Q&A, what does it all boil down to? We have the $500 billion pipeline, we have the 3 demand drivers, we have the technical defense.
I think the central finding is that this whole AI build-out is supported by these 3 really foundational revenue-generating shifts. That's what ensures demand is going to stay ahead of supply for a long time. And their technical defense isn't just one thing. It's that massive 10 to 15x jump in inference performance, plus the versatility to just run everything everywhere.
And the fact that they're already building a whole new architecture, the Rubin CPX, just to solve for long context and performance per watt, that seems like the most strategic move of all.
It is, and it brings up the one big question you should be thinking about. If they succeed, if they really drive down the cost of AI reasoning by a factor of 10 or more.
What becomes possible?
It's exactly. What revolutionary, data-heavy applications that are just too slow or too expensive to even imagine today, what gets unlocked by that leap in efficiency? Because that kind of deep, long context reasoning, that's the foundation for truly autonomous agents.
A huge leap in what's possible, driven entirely by a change in cost and efficiency. It really gives you a lot to think about as you watch this all unfold. That's all the time we have for this deep dive.
Thanks for joining us.